n factorial is 1 into 2 into 3 into so on up to n for integer where n is greater than or equal to 1. If p is equal to 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus so on plus 10 into 10 factorial, what is the remainder when p plus 2 is divided by 11 factorial? Here I would like to write it as p is equal to 1 into 1 factorial for the first term and rest of the terms are same. If we observe, every term here written is a product of number and its factorial. Like here 1 and 1 factorial, 2 and 2 factorial, 3 into 3 factorial, similarly 10 into 10 factorial. So n into n factorial is the generalization. We will add 1 and subtract 1 here, and n factorial is same. Now treat this n plus 1 as single term. So n factorial will multiply with this. So n factorial into n plus 1 minus this n factorial here will multiply with this one. So n factorial. N factorial into n plus 1. N plus 1 factorial and n factorial is as it is. Applying this, p becomes, for first term, 2 factorial minus 1 factorial. For second term, it becomes 3 factorial minus 2 factorial. For third term, 4 factorial minus 3 factorial, and so on. And for the last term, it becomes 11 factorial minus 10 factorial. If we observe, we can see this 2 factorial and minus 2 factorial cancels. Similarly, 3 factorial minus 3 factorial cancels, and eventually this 4 factorial cut the minus 4 factorial part somewhere here, and the process will go on, and this minus 10 factorial will cut the plus 10 factorial somewhere here. So we are left with this minus 1 factorial and 11 factorial. Therefore, p becomes 11 factorial minus 1. And 1 can be written as 1 factorial, which implies p plus 2 becomes 11 factorial plus 1. On dividing p plus 2 by 11 factorial, we can clearly see remainder becomes 1. This 11 factorial will divide this 11 factorial completely, giving us the quotient. So we only have this 1 as remainder. So remainder is equal to 1.